be recording this. I'm recording this because I have a student who is a seventh grader and their schedule is different than ours, and he is not able to get on the in any classes or on the Zoom. They don't have math class until after and during my planning period. So I need to record this for him. Um, so these are the things we're going to be covering today: pi, rational, irrational, squares, cubes, square roots, and cube roots. Okay. And like we just talked about, 3.14 goes on forever in a random order decimal. That's irrational. Okay, so moving on. I want you to tell me, and you don't have to write down you don't have to write down the question every single time. You can just answer the question. That's kind of what we did in class today. You can write down the number and then the answer. So what integers does, and feel free to write the question down, what integers does pi fall between? Okay. And when I mean what integers, I mean what two whole numbers, okay, positive or negative, but they'd obviously be positive. What two integers does pi fall in between? Okay. And we just estimated 3.14 for pi. So the integers that it falls between would be between 3 and 4. Okay. I swear I wrote the line first. I wrote the 4 first for some reason. Okay. So pi would fall between 3 and 4. Okay. So if pi falls between 3 and 4, because we estimate that, then what would, surely, is there, oh, there's an eraser. What would, I'm just going to change the number. I want you to keep telling me what the integers are that it falls between. So maybe you numbered that 1, number 2. This is going to be the same question. I'm just going to change what the number is. So if pi falls between 3 and 4, what does 3 pi fall between? I'm going to give you a moment to think about that. Okay. What do you think is happening between 3 and pi when they're right next to each other? Multiplication's happening. Okay. That is saying 3 times pi. Okay. Just like if it was 3 times x or 3x, that would be 3 times x. This is 3 times pi. So, I want you to try to answer these on your own and then just making little tally marks, on your paper so that you have a self-assessment on how much do you remember or how much do you need to go back and study more than what we do today on those items I listed from chapter 1 before the benchmark on Friday. Okay. Your book of math, please just kind of scroll through all those pages before the benchmark on Friday because it's going to be over all the pages we've talked about so far. Okay. Just to remind yourself, review functions and all those things. Okay. So if 3 times pi, then really we're doing about 3 times 3.14. And 3 times 3 is 9. So it's going to be 9 and some change. So it's going to be between 9 and 10. Okay. Just to be able to estimate that. Okay. It's not going to be I don't think it would ask you exactly what that is because you can't exactly calculate what 3 times pi is. But you can estimate what it's about, what it would be about between. Okay. What about the number? Square root of 20. No, I don't want to do that one. Square root of 45. All right. Now, the square root of 45 is not going to give you a whole number. Okay, it's not a perfect square. Okay, this is from 1.1. Those perfect squares, okay, like the square root of 4, that's 2. Square root of 9, that's 3. Square root of 16, that's 4. Those are those perfect squares. So the square root of 45 is not going to get you a whole number. Okay, this is irrational. Okay, this number is irrational. Anytime you don't get a whole number, it's going to give you a decimal that goes on forever, but we can estimate what two integers it falls between. The two perfect square roots that falls between is, well, I know for sure the square root of 49 is on that side. What's the other one? Square root of 36. Is that right? Yeah. Those are the two perfect ones that 45 would fall between. Okay. So if the square root of 36 is 6 and the square root of 49 is 7, then it falls between 6 and 7. Okay. Maybe 6.7. I'd say it's a little closer to the 7 than it would be the 6, but at least falls, you could tell what integers it falls between. This is particularly chapter 1, section 4, 1.4 in your book of math. That was the estimating. Okay. All right, let me give you another one. Okay. Okay. Let's do just some evaluation. Let's do some evaluation. So we're just going to evaluate. I'm done with the estimating. These are going to have exact answers. Okay. I want you to evaluate, which means just like tell me what the answer is. Okay, tell me what it's equal to. I want you to evaluate what is the square root of what's the square root of 81? Okay. Jocelyn, what's the square root of 81?
9.
9. Perfect. That's 9. Okay. All right. What is, this might be different. What is 2 square root of 81? If you see something like that, now that's a big 2 out front. That's not a little 2 perched up in the root index. It's not saying it's a square root. That is 2 square root of 81. What that means is you're doing 2 times the square root of 81. So it's just 2 times, and we know the square root of 81 is 9. So 2 times 9 is 18. That looks kind of confusing now because there's like way too many 1s and 8s on there. I didn't think that one through. Okay. So anytime there's a coefficient in the front, you have to make sure you're determining, is it a coefficient? Is it a big number that's being multiplied in the front? Or does it look like this? So let's talk about what the difference is here. Okay. Let's talk about what we notice is the differences here. Okay. What if I had cube root of 64? And then what if I had this? Let me make that a little bit bigger. Okay. So these might look the same to some of you guys, but these are actually different. These are different. Okay. I now have the chat open because I see Madison's message, and I just have it open so I can see whenever you message the answer. All right. So the difference between these two, the first one has a little bitty 3 inside, which means cube root of 64. And we just talked about the cube root of 64 was 4. Okay. Now, the other one has a big 3 in the front. That's a coefficient. That means we're doing 3 times the square root of 64. And the square root of 64 is 8. So that means we're doing 3 times 8. And 3 times 8 is 24. Okay. So just make sure when you're looking at numbers, don't look too quickly. Make sure you're looking closely and determining, is it a cube root or is it being multiplied by a 3? Okay. You have to, that will give you, as you can see, that will give you 2 totally different answers. Okay. I couldn't remember if we ever talked about when the number was right in front of it. So I wanted to make sure we talked about that. Okay. Both of these are rational because you get whole numbers for them. Okay, let's see. Now we're going to do a little, is it a little sorting? Okay, we're going to sort. I'm going to write a number down, and I want you to tell me, is it, oh, I want to start off with rational. rational, because most of the numbers are usually rational. Rational or be good if I could spell. Irrational. Okay. Rational or irrational? Okay. Let's look at, all right, what about pi?
Irrational.
Irrational, because it is a decimal. It is equal to 3.1415, blah, 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 forever, and it's totally random. So that is irrational. Okay. What if I took pi and I did 2 times pi? What do you think that would be? It is also irrational. Anytime you have pi and pi is irrational, if you multiply by 2, it's just a bigger irrational number. Okay. If I took it and I divided pi, I said pi divided by 2. Excuse me, I'm drinking a soda and it is like making me so like the carbonation. That one just like went through my nose and bubbles went through my nose. My eyes are watering. If you have pi and pi is rational, whatever you do to it, calculate with it, it's still going to be irrational. Okay. All right. What about 1/5? What about a fraction? This is from 1.3. So if you have your book of math and you open it to 1.3, the real number system where we sorted a bunch of rational and irrational numbers, whole numbers, integers, fractions, decimals, and we talked about whether they're rational or irrational. Okay. All fractions are what?
Rational.
Rational. Awesome. Okay. All fractions are rational. Okay. If it's a fraction, then the decimal equivalent will have a pattern or stop. Okay. Or repeat like with a pattern. Okay. No irrational decimals, the ones that go on forever random, none of those can ever be converted over to a fraction. So all fractions, no matter what they are rational. Okay. What about -7? Just -7.
Rational.
That's rational. Okay. That's an integer. Positive or negative whole numbers, those are integers. Those are rational. Just because it's negative doesn't mean it's rational. Okay. The only time a number is the only time a number is irrational is if it has a decimal that goes on forever that's random. That's it. Okay. Which those imperfect square roots and cube roots fall into sometimes if you don't get a whole number. Okay. What about 0.3?
Rational.
It's rational. Do you remember, Jocelyn, what type of decimals we call those when it stops? The fancy word we call decimal if it stops. No, terminates. Terminates, yeah. We don't normally say that, but that is rational. So a decimal that stops, or if you ever see the word terminate means stop, or ends, okay, those are always rational. It has to go on forever and being random to be irrational. Okay. So what about 3.271?
Rational.
Do you say rational? Yes, that is rational. So even though like the numbers, you don't see anything that's the same, that is still a decimal that stops. It would have to say like goes on forever. And usually they'd give you enough numbers to be able to determine if it went on forever or not. Okay. All right. So that one is rational. Most of the numbers in the real number system, all the numbers in the whole world, most of those numbers are rational. Okay. What about 7.232323 ...
Rational.
That is rational. So if it repeats with a pattern, that ... at the end means that it goes on forever. So if it goes on forever, then you've got to really look and see, does it have a pattern? Rational? Not have a pattern? Irrational. Okay, so that one is rational. Do you guys know what it means if you see something like 4.3 with a line over it? Do y'all remember what the line over it means? Madison, do you remember what it means if a number has a line over it?
It's repeating.
Yes, it means it's repeating. So that means it's 4.333333 forever. So that would be rational. Okay. All right. So pretty much everything's going to be rational except for those non-perfect square roots and non-perfect cube roots that you don't get the whole number. Pi and anything with pi going on. And then if you just happen to get a decimal that's like 5.3271956 blah blah blah, like it's random forever. Okay, and it has to have the dot dot dot. Okay, or it has to be said it goes on forever in a random order. Okay, because think about it, if someone's being irrational, like they're not thinking clearly, like they're thinking crazy. Okay, they're being irrational. So that decimal is crazy going on forever. Okay. Now, let me see here. I think that might be it. Okay. Let's play a Kahoot now. I'm going to play a Kahoot. Okay. Oh, I guess I have to take off to get off this screen. Okay, I can leave here. Okay, we're gonna play a Kahoot on rational versus irrational. This is the one we played back in quarter one. Okay, so it's not like a different one, but they're still fun. And then we'll be finished when we play this. Oh, they're there. Okay. All right. Oh, let me stop recording.